Hi everyone. In this video we will talk about accuracy and precision. These are very important terms for science calculation, science data, science concept. Uh, Science is all about data. We collect data and we base our theories and laws on the data. So it is very important that the data that we collect from any experiment, is it accurate or is it precise? Well, accuracy means that the results or the data that we collect is close to the accepted value. Now, what do you mean by the accepted value? Well, the density of the water is 1.0 grams per milliliter. That is the accepted value, like the known. We already know this. So we call it known value. So this is the density of the water. But let's say we do a lab in the class and the group 1 find out that the density of the water is 0.98 grams per milliliter. Another group finds out it is 1.0 grams per milliliter. The other group finds out it is 9.9, 0.99, I'm sorry, not 9.9. 0.99 grams per milliliter or 1.0. So if everybody is trying to get the density and they get the right answer, that means it is accurate. Okay, so the data is accurate. But if the first group says it is 0.5, some other group says it is 3.2, another group says it is 1.6, so this data is not accurate because it is not close to the accepted value. So this is the accepted value. So if I am pretty close, like 0.99, 0.98, 1.0, I'm close to this value. So that then the data is accurate. But if the data is like this, it is not accurate. So it is that simple. If you're right, you're accurate. If you're not right, you're not accurate. So let's say you're playing this dot game. So you're going to hit the center. So this is the only one that was able to hit the center, and none of this is accurate. Okay. On the other hand, the precision means that regardless your data is right or wrong, but everybody gets the same data. Okay. So if this data is pretty close together within a set, it is called precise. Um, so if again the density of the water is 1.0 grams per milliliter, and we did the lab in the class, and everybody is getting 1.2 grams per milliliter. Okay, 1.22 grams per milliliter, 1.19 grams per milliliter, which is again 1.2. So the data is not accurate because it's not one, but the data is precise because it is very close within a set. Um, so I think you have to do based on this, you have to do whether the following points. Like right here, let's do this one. This data is neither accurate nor precise because you didn't hit the center and it's not close together. So even if you miss the accepted value, but the data is close together, it is precise. If you don't have none, neither accurate nor precise. So this is the concept of accuracy and precision. So you have to do the bottom questions, and that's it. That's all about accuracy and precision.